Well, thank you for that introduction and reading off all of those certs. It may sound hilarious when I hear it back myself. Although I do recommend folks, if you're in this course and you're thinking about your future, check out some of the certifications that are out there. There's a lot of very good ones. Some of them are very specialized and so forth. But I actually kind of giggled inside when I heard that because I've been on the other end. And I was a Purdue University graduate. I've attended, this particular course that you guys are in, and I've spoken in person a few times in the past. And I wish we could all be there together. I'm used to, looking at a room of smiling faces and so forth. But I hope to cover any question that you guys might have with respect to this topic. So I'm going to be speaking on cyber supply chain risk management, or sometimes you'll hear it said as cyber SCRM. I like to say it out as SCRM or something like that, but I've definitely heard folks in the industry call it SCRM. So if you ever heard that, that's kind of what they're referring to. And really the focus on this topic is specifically on its impact on information in operational technology. Now, a lot of people do talk about IT, but we are going to have a little bit of a focus on operational, which are things that we use in our daily lives. It can be embedded or other, SCADA type systems or manufacturing and so forth and so on. Now, just disclaimer, the opinions, herein are my own and do not necessarily represent the views of my employer. So I will give you from my own personal experience and as best of guidance I can possibly provide, at least off the top of my head, without breaking out a book or reading something specific. All right. So I always like to kind of do these things up here in the front that are kind of like abstract. So if you kind of read it, and it's kind of the too long, don't read, summary of really what's going on here. And in this topic, we are basically looking at the interdependency that we have of really getting our components and parts, our software, and everything that we do to make a product from other folks. In fact, we find it very unlikely that folks make every single component, write every single line of software, even if it's the compiler itself that is generating the code, something is doing something for you. And so we need to understand what's going on with respect to all that and how, how maybe things could creep in potentially. Now, with respect to electronics, they're almost entirely nowadays manufactured offshore. So that may, if you have various different, trust requirements on things that you are creating that has to have a certain, trusted computing base or something along that line, there's a lot of concern there with respect to that. And folks in the past have, looked at various different concerns and identifying things that may have kind of malicious functionality from parts in which they've purchased and have them made offshore, brought them back in and say, this isn't exactly the same as what I originally designed. Is it malicious? Is it some extra, debug functionality? What is this extra thing and so forth? And then, and so what we're really going to focus in on is a little bit beyond the classic supply chain risk management, which is really more focused on, are we going to get the product on time and on budget? Where we're specifically looking at the products that we receive. Are they trustworthy? Do they have, extra vulnerabilities and so forth and so on? Now, this is important, especially in areas such as manufacturing. And where we have things are being tested and created with automated processes and automated tools and so forth. And we want to see how might cyber supply chain risk management affect what they're developing. Now, this is a statement we say a lot, and just kind of note that if you're a big company, you've got a big budget, you've got a lot of cybersecurity folks on staff, But if you really want to attack that company, you really attack their suppliers. So if you can go maybe to someone who doesn't have as much money or much funding or as much funding as some of the bigger companies, it might be easier to attack that and kind of look at that with respect to one's attack surface as ways that things might be entering into their products. So just kind of talk about some recent supply chain attacks. This was from about a year ago, in that the FBI was warning that there was lots of ongoing attacks with respect to supply chain companies. And what they're trying to do is look at folks that are supporting the industrial control systems for energy, and trying to get products in there such as remote access Trojan. If I can control your product. Now, I'm not covering SolarWinds, if anyone is familiar with real recent history, but if I can get a product, inside of the way that you run your system, then perhaps I might be able to, subvert what you're doing, and so forth. All right. Now, this was a big one from a few years ago, and I'm kind of going to talk around this particular subject. And the big hack was a huge article that came out from Bloomberg. And Bloomberg reported on this and basically said that a small little chip, and that's kind of a depiction of how big, how big it is, the size of a grain of rice, and that something so small was designed into particular boards, and that potentially could have extra functionality or backdoor capability, or something that is definitely not wanted, right? It's something you didn't design into your own product, and so forth. Now, it came out, a lot of folks did take a look at this and didn't necessarily find this particular grain of rice. But if anyone knows anything about microelectronics manufacturing, there's a lot that one can store in that tiny little space. When you hear about millions of transistors at 5 microns, and what you can do at that kind of level, things are so small. It's very easy to add additional functionality, and for folks that have to build trusted computing systems and things that are very secure, we always have to worry about this idea of trusted foundries. Are things developed onshore within the United States or offshore outside of the United States? And there are very few trusted foundries within the United States, and they seem to be dwindling every year. Every time I think that, oh, maybe that's it, there's no more left, someone will remind me, oh, there's one over here, or so forth. But there isn't that many places around, at least within the United States, that do develop the designs in which folks might do. So if you think, if you're an electrical engineer, you design out your board, you say, this is exactly what I want to do. I've got my AND gates and OR gates, and this is all perfectly how I would like it to be. When you get back, it's very easy for someone to integrate some additional extra functionality without you knowing it. And it's very difficult for you to go about determining whether or not that additional functionality is in there, whether you'd have to kind of, start to delayer your board, do destructive analysis, or if you're lucky, do non-destructive analysis and attempt to determine what is the the composition of that board, and so forth. Ripple 20 came out right about right before actually I wrote the original version of this particular talk, and it was kind of featured very heavily at DEF CON, at least virtually, and with it, there was 19 vulnerabilities that had been in a TCP/IP library that are found in many Internet of Things products. So if you're an Internet of Things vendor, you don't have a lot of costs that you're going to be able to build into your product. If you can go out and buy some feature or capability and it's cost you like a penny, you're gonna go do it because it is going to be a lot cheaper for you in the long run. And in this particular case, they were able to find 19 unknown vulnerabilities in that TCP/IP library. And one of the interesting things about it is one of the exploits allowed a cross firewall remote code exploit in that it was doing a DNS request, and that DNS request was passed and returned back. And so if you have an industrial device that just so happened to be running this TCP/IP library, it's potential that it could have bypassed your firewall, got inside your system, and have extra functionality that you didn't necessarily want to be there. So things that they've found Ripple 20 in, industrial devices, building things like big robotic arms and moving big manufacturing equipment and so forth, power grids and medical devices, which really scare me. Definitely in home devices. So, cheap, cameras and sensors and those types of things. And including, of course, network devices and things which we build our own home networks on. And sometimes small business, they use a lot of these commodity devices to kind of build just a simple little network with a simple little VPN, connected to another little network somewhere else. Those things run a lot of Internet of Things capabilities and so forth. All right. So I'm going to talk about some of the work that we did last year with respect to working with the National Institute of Technology. And one of the documents that they were coming out with was the NIST, which is an interagency report, 8276, and its title was Key Practices on Cyber Supply Chain Risk Management, Observations from Industry. We, like others, are a part of industry. And so this is one of the things that we commented and collaborated on with them and provided a lot of feedback with respect to some of the things that we might have seen in work that looking at a lot of different customers and things along that line. So these were the key summary items that they had. Now we're going to have a second version of this on the next slide, which was the ones that we recommended. But their first one was establish training on cyber supply chain risk management. It's very common that folks don't always know all the risks with respect to cyber supply chain risk management. And a lot of folks with respect to SCRM in general think, if I buy the product, if it comes to me on time, if I do, virus scan, it's okay. There's nothing there, right? So that virus scan, says it's exactly the way I thought it was, and then let's go use it in our product. And so establishing a good and detailed training program on what that might mean. What are the potential ramifications of things getting into your environment, whether it's from a hardware perspective, a software perspective, firmware perspective, all of these types of things, establishing that training and making sure that everyone is trained. And it's not just your engineers, it's not just your supply chain folks. It can be a wide variety of folks in program management and all sorts of folks, quality assurance, all of those guys. Are all part of really the team that's going to put together secure systems, and training everyone and having that is very important. The establishment of a formal program, so having folks go about the concept of really validating your supply chain, making sure that what is it they're delivering potentially is exactly what you think it is. One of the things that you'll want to do is look at your suppliers and kind of rate them with respect to the criticality they might have to a critical piece of component that you might be making. So if you're making something that is, maybe safety critical or, some other thing that needs to operate, you want to have a little bit more scrutiny in that. And so you might have a set of folks that might be a third-party organization within your own group, or you might outsource to other folks and have them come in and kind of validate what that thing is that you buy and make sure that it, it truly in fact is what they says it is. Now, integrating supply chain functions across all disciplines, that kind of gets back a little bit what I was talking about training, in that it's not just supply chain's task to ensure what is purchased is secure. It's going to involve folks in engineering. It's going to involve, really the whole entire product cybersecurity group. So making sure that everyone is trained, they know what they need to do, they're part of that formal program, and making sure that those disciplines are all in a line to make sure that what is purchased is really, truly what's going to be important to your product. Now, knowing and managing your suppliers. So this is a set of things where you're working with your suppliers and you are kind of monitoring what they're doing, making sure that they are not delivering malicious content. Let's say that you're part of that formal program and you do find, an issue. Well, getting to the next one, collaborate with your key suppliers, but collaborate with them and make sure that that doesn't happen again. And so if it does happen again, then, making sure that you're managing that and making sure that maybe you're looking at supplier redundancy, or making sure that some things are a little bit more resilient in how you both create them and integrate them into your product. Now, the collaborate with your suppliers is focused on kind of that first takeaway, which is if I'm going to attack a company, I'm going to attack their suppliers. So it is very important that organizations collaborate with those suppliers, making sure that maybe, they don't have the big IT security budget that you do. And so if you can, reach out, provide best practices, provide, various different, techniques and procedures that you see from adversaries, making sure that that they know that if you're a target, perhaps they're a target too, and what you might be doing to help them bolster their security. Maybe it's providing them equipment that maybe they wouldn't be able to normally afford, or some VPN access or authentication access, help locking down their systems. Those types of things is a good way to work with those key suppliers. And I believe a lot of them will be very receptive to that. Now, if you go to them and say, we demand you be, we're going to talk about CMMC just a little bit later, but CMMC level 5 right off the bat, they might say, we can't afford that. And that's something, you want to consider and help them along the way and get them to that kind of level. And then, of course, you're going to monitor them throughout that relationship. So just because it's good on day one does not mean necessarily that it's good on the final day. And so as you're going through that relationship, that you're making sure that, things don't creep up, or, things change over time, and so forth. All right. So these are some other ones that we had, a little bit different, has the same theme though. For us, one of the things that we've been focusing on is really, I work a lot in training and developing targeted training, not just generic training, but something specific to what that individual does on their day in and their day job. And so that does help. You got to get familiar with what they do and try to determine, how does cyber supply chain risk management affect this particular discipline, which is going to be different than, say, quality is going to be different than maybe purchasing or something like that. So there are certain aspects that they all want that are specific to the training that they're looking for. We definitely agreed with the integrating it across all levels. We'll talk about a NIST document upcoming, another NIST document talking about that. And of course, establishing that formal program. But with that formal program, having clearly defined and signed off policies and procedures by senior management, vice presidents, presidents, whoever is got the authority in your program, that everyone from top down is a part in agreeing on what that formal program is and helps instigate it and make it a part of how you do business. Now, of course, you may have defined set of suppliers that are critical suppliers. So one of the things you'll have to do is determine which one those might be. So you might have, like I said, a critical process or product that you might be developing. It might be a subsystem in a larger system, or it's a board on, on this little chassis or this embedded device. That thing right there is the most critical aspect of your system. Other things might not be as critical. So definitely making sure that you're working with those that you feel is most critical, having a little bit of extra scrutiny with respect to what that is, because that is really what makes your product so great, right? People love your product because of this whiz bang thing. And if they're a part of that, making sure that they are, extra specially taken care of. Of course, understanding your supply chain, it is often very difficult to know who your suppliers are. And I don't think I could say suppliers enough. And in fact, it can keep going on and on and on. And if you do any kind of research in the area of supply chain risk management, or in cyber specifically, you'll find this kind of finger drawing where, one thing leads to another thing that leads to another thing that leads to another thing that eventually gets into your system. And you'll be surprised how in-depth it might go. All right, let's see some of the other ones we got on here. I definitely collaborate with, I would say really all your suppliers, but if you had to, if you can only afford a little bit, maybe you do identify some key specific ones, other ones you have a certain level of trust that you're working with. So making sure that you're, using your funds correctly. Now, there are various different cases where you want your products to be resilient, and you also want to have a resilient supplier base where you have more than one supplier, or you might have one that develops it for, let's say, ARM processors or Intel processors. They might be completely different. And one of the things that we always try to consider with respect to building secure systems is what happens when we get exploited. What is the resiliency that has to take place with respect to that? And it could involve buying a component that does this one thing that is different than another component, and that resiliency is extraordinarily important. And of course, monitor them throughout the entire relationship, and really think about that full life cycle. And a lot of people do tend to forget that eventually things do get disposed of. We don't want to see things in landfills with, special firmware installed or chips, they are disposed of correctly and data is properly purged and so forth. All right, so here's some examples and important things that folks might want to look at with respect to providing guidance with respect to cyber supply chain risk management. And the biggest one right now is what's going on with the Special Pub 800-161. And then additionally, I'm going to talk a little bit about the recently updated NIST Special Pub 853 in the upcoming slides. In this specific guidance on supply chain risk management, it is, it's kind of listed for federal information systems and organizations, but a lot of folks adopt this particular document and methodology. Now, note, draft 1 is coming. So it always cringe every time when I make a slide and then I see, oh man, this hasn't been updated for 6 years. It's coming. It's not quite out yet. The current one still references the older NIST revision, but it goes in depth on looking at your organization, looking at all of those capabilities and roles. And it does provide in section 1.7 a methodology for building this this kind of group from scratch. And so the ICT is integrated communications technology, which is basically everything that produces ones and zeros. So they provide guidance on using the NIST Special Pub 839, which is managing information security risk. That's important because you don't want to spend money on places, you don't need to be spending money. And that's kind of why I kept bringing up criticality a little bit. Determining what's critical on how your product is going to run and execute and what really keeps it working. Those are the things you want to focus on. So you want to have that kind of risk management along the way to ensure that you are tackling and going and looking at the right items. Now, it specifically calls out how to apply the NIST security and privacy controls, which was under NIST Special Pub 853 revision 4. And I added the bracket now revision 5. So I do have that in the next slide, which I will cover because they did some interesting things with respect to how it used to be in the controls document. And those of you who aren't familiar with these particular documents, the 853 is probably one of the most famous documents out there in that people kind of equate that to security requirements. Like I might have access control requirements or something along that line. One of the sections in there was specific, actually it was a subsection, I believe it was called SA12 on supply chain risk management. So move on to the next slide. One of the things that they did is they pulled that out into a major level, and they kind of started to see what they could do to integrate supply chain across the document. And so they came up with a supply chain risk management family, or you'll see it bracketed SR. So you have policies and procedures and the various different controls, and it talks about things that you'd want to be thinking about if you're building in supply chain. Now, provenance, pedigree and provenance, who has it and where who created it, and understanding who created it is extraordinarily important, because it may be a mom and pop shop who wrote some code base that gets integrated into something else, which then gets integrated into your products. And so if you're in the, if you were looking at the vulnerability I was just talking about, where the TCP/IP vulnerability, that was a small company wrote a TCP/IP library. It was integrated into major operating systems that are more focused on embedded type systems. Those were integrated into a targeted board that folks created, made their product out of it, and it got brought in. And so in this particular case, you would look at who had the ability and touched the product all the way along the way. The assessment and reviews. So eventually at some point you will have to assess the work that they're doing. I mentioned maybe potentially utilizing a third party, like an internal third party is really helpful, but if you can definitely work with them and make sure that, when you're bringing in, let's say, source code from that mom and pop shop, that you might be doing things such as static code analysis and running various different tools and doing really a full static application security test of what is it they're developing. You may also potentially be doing dynamic analysis. And that dynamic analysis may, definitely run the code in its targeted environment and maybe fuzz it, check for memory reads and writes and all of those types of things, and see how it works in nominal and off nominal situations and so forth. There's a whole bunch of others on here. I'm not going to touch on them all, but I do want to recommend folks take a look at this, especially if you are new to supply chain and trying to think of what controls that your programs or companies should be looking at with respect to applying to the processes and things that you're doing. There's a lot of great stuff in here, including that very last one, component disposal. Now, actually, I'm going to go back up one. Authenticity is an extraordinarily important thing. I apologize for skipping it. people have been creating products that look nearly identical to other products. In some cases, they actually exceed the capability of the original product. In these cases, they've basically reverse engineered all of the components. They've created their own parts. It looks nearly identical to it, and you build that part and put that part into your environment, and you think about that authentic part may work and may not be malicious, but it may not work in all situations where you bought it because it runs at 500 degrees, and when you do reach that temperature, it burns up, and then it's not as good as you'd like it to be, and so forth. All right, so all of this is really great, but how does this really impact information technology, and specifically operational technology? Now, of course, attackers are going to attack your suppliers. Now, this does include things that you buy to integrate into your company as a part of the things in which you manufacture. Now, one of the things that folks might want to do is create malware specifically targeted to your product, to attempt to maybe get a copy of your source code, get a copy of your hardware device or hardware designs, however you laid out your chips, maybe potentially create counterfeits or duplicate systems that look identical to yours, as I was mentioning, basically leading to a loss of intellectual property. And if you do any kind of Google search on, folks targeting, the United States and trying to, potentially get their intellectual property, it's a lot. So every year the number is bigger and bigger and bigger, it seems like. All right. Now, if you're manufacturing and you're buying equipment and you're integrating it as a part of how you're developing your systems, what you want to make sure that the things that you're utilizing to test and validate that what you're developing is good, to make sure that that system does not pass when it should not pass. Perhaps it's saying, system's great, I'm going to let it go on through, no big deal. Or there might be some, certain circumstances where it shouldn't pass, right? But they're going to allow that to pass. Now, also, it may have extra firmware, other capability installed that you might not necessarily want. And then, of course, you're passing things, right? So if you pass a system, you say, yes, I ran it through all of my system tests. That system test says it's okay. I'm going to go ahead and let it send it to my customer, and my customer runs it and it fails. And he's doing his own vendor tracking, right? He's looking at me as being a supplier to him, and he's saying, oh, well, that guy didn't necessarily deliver a good product. Well, the next time he really didn't do a good product. And then we lose that customer trust, and it's definitely something that no one wants to have. And so forth. Anyway, the false pass rates can really trick you up. And another thing that you might potentially be concerned about is what relationship you have to the folks that maintain the equipment that that pass your systems. So you might have a situation where a vendor shows up, they show, hey, I'm, the maintenance guy for product X, and they are allowed to go in and find the debug port into product X, plug into that, upload some extra fun firmware, and, and let that potentially on through. And so there's always a certain set of trust that one has with, things that you do in test equipment and so forth and so on. All right. Now, all organizations really should have a cyber supply chain risk management capability, and you need to have a method to respond to when things go wrong, and kind of go under the assumption that what happens when things do go wrong? What is my disaster recovery, continuity of operations? Like, how do I keep how do I keep going? And what happens when a vendor contacts me and says, well, I've been using that thing that caused Ripple 20. I don't think you knew about it, but Ripple 20, has a lot of unknown vulnerabilities, and it's in my product. Now it's in your product. You should be aware. Now, when do they tell you? Is it a 30-day, 60-day, 90-day thing? How do you respond? How do you tell your customers? What is your vulnerability reporting? Whether you have a full, common vulnerability and exposures, process or so forth. How do you respond to all of that? Now, there are various different ways to specifically combat risk. Now, sometimes folks will say, well, all this is great, but I really don't have the funds to do that. So you might end up going with a third party. Now, UL, the folks that you'd commonly find on like light bulbs and stuff like that, have been working on a supplier trust level, and level 1 nascent. And as I mentioned, things such as criticality kind of equate that to that. So something's low criticality, they might be nascent, or I'm sorry, I said that wrong. The criticality would be affected by their level of trust. And so if you have a critical critical supplier and they are nascent, that means that maybe perhaps they don't have very many cybersecurity practices, and then you'd want to go in and work with them and help that supplier along. And so to rate folks, you could have a nascent, a challenger, a contender, a strong performer, or a leader. And we do hope that everyone on here does strive to be a leader and really has that highest trust. They're putting out good code, no known vulnerabilities or weaknesses in their products, definitely no design flaws or anything along that line. And they're working with their suppliers to make sure that their suppliers and their suppliers, which is that 2-tier relationship, that they are also becoming strong performers. They're also becoming leaders in the way that they're delivering their capabilities today. All right, so what should one be doing after listening to this talk? First, definitely get educated on specific issues. IT is different than operational technology. I tried to do a little bit more focus on operational technology today. There's a lot I could say on IT in addition, but I think that subject has really been covered quite a bit. And embedded systems and things that we use day in and day out, our daily lives, do sometimes get missed. And it's going to be different, right? So IT, if it crashes, I reboot, but OT might mean I have a problem, or my production line stops, or something is not going to be the way I want it to be. It's not just a blue screen of death at that point. Now, develop a specific set of questions for your suppliers. Just some example ones, do they have an application security program? We tend to use the word software assurance. So whether you use those two terms, basically, what are they doing to deliver and implement secure coding and have that throughout their life cycle and deliver to you as someone that you're going to integrate into their product, into your product. Now, one of the things that's recently come out is a cybersecurity maturity model certification, or CMMC. As that starts to mature, we'll see folks get assessed for the certain level of capability that they have. Very, similar to the UL provided trust levels in some ways, but basically the more capabilities that they get, you'll be higher up the scale. Now, kind of think of it very similar to other CMM or CMMI done out of Carnegie Mellon, or SCI, that the same kind of rating, the same kind of structure, and so forth. Now, do a component risk assessment. So look at each component. Try to figure out, one way to categorize them, whether it's UL or something like that. Figure out what kind of testing you might want to do. You might want to say, for this vendor, I'm going to specifically do static analysis. I'm going to check every line of code that they have. I'm going to do pedigree, provenance for whatever it was, make sure it's not just some open source code that they just copy and pasted, straight into their product, and try to understand what that is, and make sure that you implement that across your components. Now, you also may want to use a third-party vendor, and I just kind of just a quick list. I think at the time I just kind of Googled third-party vendor, whatever you feel might be a good choice. But these companies, they go out and they look at products, they look at maybe known issues with various different vendors, and they'll rate them based on their perception of that particular vendor. So if you don't have a method or a way to understand what's being done, then perhaps they might provide some guidance for you. And then, of course, still probably number one, partner with your suppliers and make sure that your suppliers aren't just feeling like, okay, I give my product to this other person and that other person just takes it and then scans my code and tells me my code is bad. That you're working with them and providing feedback and say, you guys have a lot of buffer overflows. Maybe we could provide for you some secure coding training that we might have. So here's some example code. Here's ways to fix that. Let's validate our input. All of those wonderful things. Partnering with their suppliers can go a long way to make sure that they build that security into their products, build it into your products, and so forth. And then eventually, of course, everyone has to have a plan. So as you develop your product, have a cyber scrim plan all the way from make buy decisions all the way to the very end. How are you going to handle it? In some cases, some folks will work with vendors and they will have third parties that host the source code, and just in case the third party goes out of business. And so they will do that and have that capability. So if the third party does go out of business, then you'd want to go in and have rights to maybe get access to that in case you need to update it over time. And so whatever is important to you, you put that in your supply chain risk management plan, and then work with your vendors and so forth. Now, here's a set of references, some of the ones we called out today. I think that is about it. And so I think we're ready for question and answers. Which I haven't seen any posted on the Q&A or the chat, but if you have a question, you can go ahead and enter it. That would be totally okay. Either one, I've got them both up. Like I said, while you guys are thinking of questions, I will note that one of the questions we had beforehand, we had a question about threat modeling and maybe how threat modeling applies. And I think threat modeling is extraordinarily important. It does help you determine what's critical to you and where an attacker might go at you. And when I kind of generically saying, if someone's going to attack you, go look at your suppliers, but they might come at you at various different other ways too. And so even threat modeling your suppliers would be a really cool thing to do, and determine how might your suppliers wiggle your way into your product. Okay, so we have a question. Can you elaborate on a specific case of discovering a threat and how it was handled? So I'm not allowed to talk specifically on things that happened in particular with my own company. But I can tell you that, and I will generically talk about the issue with respect to SolarWinds. So if those of you aren't familiar with that particular tool, it has been used in a lot of network security environments, and in some people have very much called this a supply chain attack. Now, one of the things that you'll want to do as someone who writes code is that supply chain you'll have to have a way to update the code. And so what they did is they updated their code just like normal, and somehow someone got access to their repository, their code signing cert, and so forth. And it was very difficult and a tough situation for them to deal with. And a lot of folks wouldn't have necessarily found that particular exploit, but there was a lot of, work being done to kind of communicate, what's going on with that. And I think the whole community came together and really handled it in a very good way, working together, exchanging, various different ways to, do indicators of compromise, find various different issues, maybe provide different ideas on how one might go about, scanning for such a type of thing, right? So a lot of times if you don't have, a static binary analysis where you're looking at what does the binary do? If the binary is opening up a socket when it's not supposed to, a lot of people don't do that. So there's a lot of tools that are available, whether you're using IDA Pro or Ghidra or some of the other kind of reverse engineering tools that are out there. There's a lot of things that can be done. Now, with respect to handling threats, I mentioned it's very good to have a certain time frame. So whether it's 30 days, 60 days, 90 days, or even in some cases 24 hours, right? So if I get a problem, 24 hours we're telling everyone or something like that, that might be the requirement. So having those defined, I think, is very, very important with respect to discovery and letting that out. So now I do have a question so I'm going to answer it live. I guess I pushed that button, but I'll read it first. And it says, one may consider using a software escrow service when bringing in third-party software components into their product. Yes, that's exactly some of the things I was mentioning about having that third party. Actually, a lot of people forget about escrow services. They do exist. And as if you're buying something from a company, maybe they might not necessarily know whether or not that company is going to be in business in 5, 10, 15 years. And considering that software escrow might be a good idea depending on what might happen. And so that might be something, it's kind of between you and your supplier and so forth. I had a couple come in on chat, so I'm gonna hit answer live on that one, and let me scroll back up. I had a couple come in, so let me try to take them in order. How would you consult someone about social engineering attacks? A lot of companies don't realize someone can basically kind of call them and pretend to be someone. If you ever get a chance, I strongly recommend you attend if you go to like a conference like DEF CON, try to get into the social engineering village. And about a year ago, there actually was a social engineering conference in particular. And there's a lot of great examples about, folks creating websites out there, having exact, have pictures, looks just like a company website. It might say, that company's name dot, questions.com, and they'll say, hey, we're having trouble validating, maybe we'll just throw suppliers out there, right? So, can you enter your key suppliers in here so we can double check them and make sure that they're not on any list of, delivering bad stuff. And so you get tricked very easily, like, oh, okay, all they want to know is just who my key suppliers are. So now they know who your key suppliers are. So if they can go, take them out, it's so easy to trick people. I have seen, and I'm not a social engineer. My joke about social engineering is basically, so I lock down my system and someone goes, what's your password? And you're like, SolarWinds 1, 2, 3, 4. If it's that easy, then, someone just tricks you and you just give up the password. And I've seen so many even smart, intelligent people be tricked from social engineering. I would say education is great. Knowing what to do when you do get that fish or spearfished is very, very good. I know Kevin Mitnick puts out a lot of courses along that area, and there's a lot of some companies that he works with that do put out training in that area. And there are third parties that do targeted social engineering to kind of see how does the organization doing with respect to identifying social engineering tricks. All right, I'll move on to the next one. It says, what do you think about Bloomberg doubling down on the supplier chain you mentioned, despite producing any public evidence of their claim? Yeah, I was following that very intently because I personally don't know whether or not there was something there, but when I think about how small the chips are getting, and they're getting smaller and smaller to a point that maybe you can't find things, maybe it was or wasn't there. I don't really know, but it does give me pause for thought, right? You look at a system board. If I hold up a system board, can you tell me what's on that board? There's a lot of stuff there, and I can't tell you that all the transistors are exactly the way that I originally designed if I don't have a good method to validate that. So all I can say is they did double down, as Drew was mentioning, and they were very adamant that, and I don't think even today have they retracted anything. So I'm not Bloomberg, but they seem to be very adamant that that was definitely the case. All right, I have one that's sent to me directly, so let me see if that's actually a question or and so forth. Oh, so the question is really around small manufacturers and not having the security staff. A lot of folks there is. So if you guys are taking this course, I can tell you, I went to Purdue University. I had a lot of job offers. I luckily had a nice conversation with Dr. Spafford, and I said, hey, I have all these. Which one should I take? And he was like, you take that one. And that one was a network security job. There's just a huge shortage out there of really good people. I think some people say, well, there's millions of unfilled jobs. Well, yeah, there's a lot of jobs out there, but really good people. And you guys are going to Purdue. I have high faith in you guys all. And I think that, you guys can fill a lot of those roles. And whether you're small or maybe even moderate sized, you might not always have, all the people that have the kind of training that you guys have had or something along the line. So it depends. It really depends on the quality. Like I definitely have talked to folks that'll be like, I'm like a few people, and I'm like, wow, that guy's like, he's going somewhere. He's very smart. And so I would say that to the answer to the question, I would say it depends, right? It really depends on the person working the job. And I can tell you honestly that cybersecurity is just plain awesome. And I strongly recommend it. Keep going in cybersecurity, and especially if you ever get into understanding like how exploits work, and you make an exploit work and you understand everything about it, it's interesting. It's kind of like when you lock pick and you finally pick that lock. It's really kind of cool. So I recommend it. So you might want to mention diversity of roles in our field. SOC, CERT, audit, compliance, just my 2 cents. I'm assuming you mean doing both security operations and incident response, and then kind of like transitioning into audit and compliance. Yes, and this isn't necessarily like okay, yeah. To Paul's statement, there in cybersecurity, there is everything. And if someone asks me like, what area of cybersecurity do you special in? And I go, CISSP. And they're like, really? I'm like, yeah, I'll do everything. And there is a wide range of jobs, whether you're doing compliance, which compliance can just be like a check in the box, to implementing cybersecurity, to reverse engineering, to I'm a developer and I write secure code. I'm a secure architect. I'm a cloud security person. I am, you know, all of those. As someone who's done a lot of different roles, changing what you're doing every so often is really kind of good. You will find different points of view, and it will definitely make you a better cybersecurity person. I know if I kind of come in and be like, okay, I'm cybersecure, you know, I'm the cybersecurity person and I'm here to make everything better. Oh, by the way, your software is not so secure. You know, we've done these static analysis tools on it and it says this, and I've gone through it and I've kind of like validated those things. You know, just saying what a tool says isn't really that great, but understanding exactly why it works the way it is, especially coming from like a programming background and understanding how software, you know, is put together is very important. So having a wide range of jobs. I mean, I've done network security. So network security led into network intrusion detection, which led into vulnerability identification, which included vulnerability reverse engineering, to exploitation, to, you know, how is that done in other, you know, other industries. So definitely wide variety of jobs, very cool to look at. Okay. I think that's it. That last one had nothing to do with really supply chain, but.
Thank you so much for joining the CERIAS seminar, and we'll make videos available in our YouTube channel.
Okay. Alrighty.
All right. Thank you.
All right. Thank you, guys. Bye.